Welcome back. I'm John, an old YouTuber. It's very hot in my living room because I closed the door because of my voice and the voice from my computer. But I got a small break and did eat a little bit food. I forgot to eat some food today because of the heating. So I'm just record 2 Dennis videos. Now I used to, it's 29 degrees. I used to have the door closed when I do this computer voice because I have people living around me. So they probably like to sit on the balcony without listening to Intel Core Microarchitecture. But now I did read the P6 Microarchitecture and the net burst, so why not read the Intel Core Microarchitecture? That's probably for the Pentium D and Pentium Dual Core and the Intel Core, but this list is growing. I like to get back to read about the CPUs, but I like to read that too, so but every time I read a PDF, I'm getting 1 new or 2 new. If I keep doing that, my list will grow and grow and grow. So I have to read some PDF without adding. I'm not adding more to the lists. If not, my list will keep growing. This is how I end up to have like 30 pages. So, but I like to read this. Yes, I need half a minute to do myself ready. I'm laying in my bed. This text is a little bit small, so and my eyes are not. I need new glasses. I need reading glasses. So this text is a little bit small. Read to end of documents.
Intel Core Microarchitecture. Intel Core General Information Launcher June 26, 2006. Xeon. July 27, 2006. Core 2. Performance Max. CPU clock rate 933 MHz to 3.5 GHz FSB speeds 533 mount /s to 1600 mount /SCHL 1 cache 64 KB per core L2 cache 0.5 to 6 MB per 2 cores L3 cache 8 MB to 16 MB shed. Xeon 7400. Architecture and Classification Technology Node 65nm to 45nm Architecture E8664 Microarchitecture Core Instructions x86, x86-64 Extensions MMX, SSE2, SSE3 SSE3, SSE4, 45nm Core 2 only, VTX, Sum. Physical specifications transistors 105M to 582M, 65nm, 228M to 1900M, 45nm. Cores 1, 4, 2 to 6 Xeon. Socket S, Socket M, PGA 478. Socket P, PGA 478. Socket T, LGA 775. Socket J, LGA 771. Socket 604. FGA, FGA 479. FGA, FGA 965. Products, models, variants model, S, P6 family, Celeron Pentium Dual Core, Core 2 range, Xeon. History. The Intel Core Microarchitecture, provisionally referred to as Next Generation Microarchitecture 1, and developed as Meron 2, is a multi-core processor microarchitecture launched by Intel in mid-2006. It is a major evolution over the Yona, the previous iteration of the 6P microarchitecture series, which started in 1995 with Pentium Pro. It also replaced NetBurst microarchitecture, which suffered from high power consumption and heat intensity due to an inefficient pipeline designed for high clock rate. In early 2004, the new version of NetBurst, Prescott, needed very high power to reach the clocks it needed for competitive performance, making it unsuitable for the shift to dual forward/multi-core CPUs. On May 7, 2004, Intel confirmed the cancellation of the next NetBurst. 3. Intel had been developing Microarchitecture, the 64-byte evolution of the Pentium M, since 2001-2, and decided to expand it to all market segments, replacing NetBurst in desktop computers and servers. It inherited from Pentium M the choice of a short and efficient pipeline, delivering superior performance despite not reaching the high clocks of NetBurst. A. The first processors that used this architecture were code-named Microarchitecture, Conroe, and Woodcrest. Microarchitecture is for mobile computing, Conroe is for desktop systems, and Woodcrest is for servers and workstations. While architecturally identical, the three processor lines differ in the socket used, bus speed, and power consumption. The first core-based desktop and mobile processors were branded Core 2, later expanding to the lower-end Pentium dual-core, Pentium and Celeron brands, while server and workstation core-based processors were branded Xeon. Contents. Features. Roadmap. Technology. Processor cores: Conroe /Microarchitecture, 65 nm. Conroe L /Microarchitecture L. Penryn /Wolfdale, 45 nm. Dunnington. Steppings using 65 nm process. Steppings using 45 nm process. System requirements: motherboard compatibility. Synchronous memory modules. Chip errata. See also. References. External links. Features. The core microarchitecture returned to lower clock rates and improved the use of both available clock cycles and power when compared with the preceding NetBurst microarchitecture of the Pentium 4 and D-branded CPUs. 4. The core microarchitecture provides more efficient decoding stages, execution units, caches, and buses, reducing the power consumption of Core 2 branded CPUs while increasing their processing capacity. Intel CPUs have varied widely in power consumption according to clock rate, architecture, and semiconductor process, shown in the CPU power dissipation tables. Like the last NetBurst CPUs, core-based processors feature multiple cores and hardware virtualization support, marketed as Intel VTX, and Intel 64 and SSSE3. However, core-based processors do not have the hyper-threading technology as in Pentium 4 processors. This is because the core microarchitecture is based on the 6P microarchitecture used by Pentium Pro, 2, 3, and M. The L1 cache of the core microarchitecture at 64 KB L1 cache /core, 32 KB L1 data plus 32 KB L1 instruction, is as large as in Pentium M, up from 32 KB on Pentium 2 /3, 16 KB L1 data plus 16 KB L1 instruction. The consumer version also lacks an L3 cache as in the Gallatin core of the Pentium 4 Extreme Edition, though it is exclusively present in high-end versions of core-based Xeons. Both an L3 cache and hyper-threading were reintroduced again to consumer line in the Nehalem microarchitecture. Roadmap. Technology. Predecessor NetBurst enhanced Pentium M, 6P, successor Penryn, TIC, a version of Core, Nehalem, TARC. Intel Core microarchitecture. While the Core microarchitecture is a major architectural revision, It is based in part on the Pentium M processor family designed by Intel Israel. 5. The pipeline of core/Penryn is 14 stages long. 6. Less than half of Prescott's. Penryn's successor Nehalem has a 2 cycles higher branch misprediction penalty than core/Penryn. 7. 8. Core can ideally sustain up to 4 instructions per cycle, IPC, execution rate, compared to the 3 IPC capability of 6P, Pentium M and NetBurst microarchitectures. The new architecture is a dual-core design with a shared L2 cache engineered for maximum performance per watt and improved scalability. One new technology included in the design is MacroOps Fusion, which combines 2 x86 instructions into a single micro-operation. For example, a common code sequence like a compare followed by a conditional jump would become a single micro-op. However, this technology does not work in 64-bit mode. Core can speculatively execute loads ahead of preceding stores. 9. Other new technologies include 1 cycle throughput, 2 cycles previously, of all 1 to 8-bit SSE instructions and a new power-saving design. All components will run at minimum speed, raising speed dynamically as needed, similar to AMD's cool and quiet power-saving technology, and Intel's own speed step technology from earlier mobile processors. This allows the chip to produce less heat, and minimize power use. For most Woodcrest CPUs, the front side bus, FSB, runs at 1333 mount/s, however, thighs is scaled down to 1066 mount/s for lower end 1.60 and 1.86 GHz variants. 10. 11. The Merom mobile variant was initially targeted to run at an FSB of 667 mount/s, while the second wave of Meroms, supporting 800 mount/s FSB, were released as part of the Santa Rosa platform with a different socket in May 2007. The desktop-oriented Conroe began with models having an FSB of 800 mount/s or 1066 mount/s with a 1333 mount/s line, officially launched on the 22nd of July. 2007. The power use of these processors is very low. Average energy use is to be in the 1-2 watt range in ultra-low voltage variants, with thermal design powers, TDPs, of 65 watts for Conroe and most Woodcrests, 80 watts for the 3.0 GHz Woodcrest, and 40 or 35 watts for the low voltage Woodcrest. In comparison, a 2.2 GHz AMD Optron 875H processor consumes 55 watts, while the energy-efficient socket M2 line fits in the 35-watt thermal envelope, specified a different way so not directly comparable. Merom, the mobile variant, is listed at 35 watts TDP for standard versions and 5 watts TDP for ultra-low voltage, ULV, versions. Previously, Intel announced that it would now focus on power efficiency, rather than raw performance. However, at Intel Developer Forum, IDF, in spring 2006, Intel advertised both. Some of the promised numbers were 20% more performance for Merom at the same power level, compared to Core Duo. 40% more performance for Conroe at 40% less power, compared to Pentium D. 80% more performance for Woodcrest at 35% less power, compared to the original dual-core Xeon. Processor cores. The processors of the core microarchitecture can be categorized by number of cores, cache size, and socket. Each combination of these has a unique code name and product code that is used across several brands. For instance, code name Allendale with product code 80557 has 2 cores, 2 MB L2 cache and uses the desktop socket 775. but has been marketed as Celeron, Pentium, Core 2, and Xeon, each with different sets of features enabled. Most of the mobile and desktop processors come in two variants that differ in the size of the L2 cache, but the specific amount of L2 cache in a product can also be reduced by disabling parts at production time. Tigerton dual cores and all quad-core processors except Dunnington QC are multi-chip modules combining two dies. For the 65nm processors, the same product code can be shared by processors with different dies, but the specific information about which one is used can be derived from the stepping dot for chorus mobilidsk top. Up server CL server DP server MP server single core 65nm 65nm1 Merom L80537 Conroe L80557 single core 45nm 45nm1 Penryn L80585 Wolfdale CL 80588 dual core 65nm 65nm2 Merom 2M 80537 Merom 80537 Allendale 80557 Conroe 80557 Conroe CL 80556 Woodcrest 80556 Tigerton DC 80564 dual core 45nm 45nm2 Penryn 3M 80577 Penryn 80576 Wolfdale 3M 80571 Wolfdale 80570 Wolfdale CL 80588 Wolfdale DP 80573 quad core 65nm 65nm4 Kentsfield 80562 Clovertown 80563 Tigerton 80565 quad core 45nm 45nm4 Penryn QC 80581 Yorkfield 6M 80580 Yorkfield 80569 Yorkfield CL 80584 Harpertown 80574 Dunnington QC 80536 core 45nm 45nm6 Dunnington 80582 Conroe /Merom 65nm. The original Core 2 processors are based on the same dies that can be identified as Cluid Family 6 Model 15. Depending on their configuration and packaging, their code names are Conroe, LGA 775, 4MB L2 cache, Allendale, LGA 775, 2MB L2 cache, Merom, Socket M, 4MB L2 cache, and Kentsfield, multi-chip module, LGA 775, 2x4MB L2 cache. Merom and Allendale processors with limited features are in Pentium dual-core and Celeron processors, while Conroe, Allendale and Kentsfield also are sold as Xeon processors. Additional code names for processors based on this model are Woodcrest, LGA 771, 4MB L2 cache, Clovertown, MCM, LGA 771, 24MB L2 cache, and Tigerton, MCM, Socket 604, 24MB L2 cache, all of which are marketed only under the Xeon brand. Processor brand name model, list, cores L2 Kakasekt Merom 2M Mobile Core 2 Duo U7XXX22. MGA 47910 Merom 7XXX4MB17 Merom 2 Mount 5XXX. T7XXX24MB Socket M Socket PBGA 47935 Merom Mobile Core 2 Extreme X7XXX24MB Socket 44P Merom Celeron M5X011MB Socket M Socket 30PW Merom 2 M5X5 Socket 31PW Merom 2M Celeron Dual Core T1XXX 2512 1024 KB Socket 35PW Merom 2M Pentium Dual Core T2XXX T3XXX21MB socket 35P Wallendale Lexion 3XXX22 Logger 77,565W Conroe 3XXX24MB Conroe and Allendale Core 2 Duo E4XXX22 Logger 77,565